Okay, today is day 3 on linear programming, and we're introducing graphing inequalities and introducing the linear programming process. Basically, I've already introduced it to you. This is actually a review of that part. But we're really going to get better at how to use your calculator well for this stuff. Everybody, would you please put in negative 2x plus 6 on your graphing calculator? And then how do you shade below a line? Did you know you could get your calculator to do that? So type in negative 2x plus 6. I'm going to pause for a second. Okay, I got the kids paired with somebody, and in a moment we're going to get comparing to see if they don't get how to do this. Negative 2x plus 6 is easy to type in. You've been doing this forever. The question is, if you graph it, do you know how to get it to shade underneath it? Or above it? All right, here's how you do it. Go back to the y equals, and arrow to the left. You see those little slashes on the left-hand side? That's how the line's going to appear when the graphing calculator does its thing. So to get the line to be different, I'm going to go and choose that. Now, I know none of you probably have the brand new color one, which is what I have, so yours looks a little different here. But when you hit enter, it changes these, the lines. You can't change colors, of course, but you can change the lines here. And there's shade above. Look at how it's a triangle. That's like an up triangle. There's shade below, and there's shade darker line, dotted line. There's even this one. Everybody find the one that looks like a negative 0. And then hit graph, and just see how it appears differently. It's almost like a little pen is drawing the line for you. Why is that good? Because if you have 3 lines that are being graphed, and you really only care about one of them, like you want to see this one, like which one's which, like there's 3 lines, they all look the same to you. You can change one of them to be the one that's drawn by the pen. You get what I'm saying? All right, go back to this y equals, and this time let's have it shade above. So everybody get in there, and I personally have to arrow down, and you just have to hit enter a few times. Get it to change to the one that's the triangle where the pointy is on the upper right. Shade above. Hit enter. And it says now instead of a slash, it's got a triangle there. So when you graph, it shades above the line. Now mine shades in blue above the line. Yours just probably is just a black and white screen, so it just shades darker above the line.
There's 3 different patterns and 3 different screens.
You're right. This is a computer, and so it can do anything. But the blue calculators that are graphing calculators, they have colors. So, like if your calculator were to die tomorrow, they only charge like literally $5 more for this one, which has the color options on the screen. There is a downside because the screen is much more like high tech or high, like lots of pixels. It takes longer for it to graph things, not tons longer, but a little bit longer to graph things, but it can do colors. So you can have this line be red, that line be green, that line be blue, and then see where they all intersect. And yes. All right. All right. Then I will come and check yours. Here we go. So we're back, and this is y equals negative 2x plus 6, except it's shaded above it. All right, so now, what's really important is to understand how to find where 2 lines cross. So I'd like to go to this next slide. Everybody go to this one. And we've got 2 equations that I want you to find, the red one and the black one. They intersect right there. So how am I supposed to find the equation for that? You're supposed to know where the y-intercept is and what the slope is. And so you should be able to find that red equation right now. Y equals, you have to figure out its slope. You have to figure out its y-intercept. Now I'll give you a hint. A lot of people think it's negative 2. It's not. It's going from here to here. So you've got to judge its rise over run, and it's falling and running. So finish it. What is it? And that's not 1/2. Negative 3 over 2. That's negative 1 and 1/2. Go ahead. But that's not an equation. There we go. Negative 3 over 2x plus 6. That's the red equation. Now, use that same process and figure out the black equation. Then, put both equations in your calculator and see where they cross. They should cross at 2, 3. But if you don't know how to do second calculate intersect, this will show us that. Again, if you're having trouble with that, that's why I paired you with somebody. Would you please ask them first, at least? I can't come and solve all individual tech questions. There's 30 of you. 1 minute spent with each of you is 30 minutes. I can't do that. I can't. Don't have time. I'm almost out of time here.
Are you recording?
I am recording.
Hey.
Okay, just to make sure you're not graphing the wrong thing, you should be graphing negative 1/2 x plus 4 and negative 3/2 x plus 6. Then second calculate intersect. Okay, I was asked a good question. Do we need to shade this? Well, we have to assume that it was already shaded. Now, just so you know, I know most of you are thinking that the shaded region would have been this one, and it usually is. But sometimes they have you shade, like in today's problem, in a totally different way. Like today's problem, they're going to have you shade above this line, and above this line, and above the green line. And where do those all intersect? They intersect here, and it has no end on the one side. It just keeps going forever in this direction. Is that okay? Yes, it is. It is okay, because then they're going to ask you for a minimum. So in other words, remember how I always said that the corners are the area that where the answer could be? All right. Now, I did something here that is important to note. I allowed for a negative x. Like, do you get in here? How would you have a negative x? All right, so what were you supposed to always have? Something, common, remember what they're called? Common sense constraint. The common sense constraint is that it can't be negative. So really, it should have a line right here, and you always have to shade on this side up to keep it positive. Okay, so anyway, there. Now here's my new feasible region, and it has no end. It goes forever that way. That's okay. I know it doesn't feel the same, but the corners are still the answer. It's either that, or that, or that. And in this case, we want to minimize something. Maybe it's we want to minimize cost. Like, let's say that we're buying this and this and this, and we're going to take these, well, let's just keep it simple. Let's say 2. Do you get that multivitamins have different amounts of vitamins in each multivitamin? Like, this multivitamin might be really good for calcium, but it doesn't have much vitamin C in it. And this other multivitamin over here has got a lot of vitamin C, but not much calcium. And so I know a lot of people just say, I'll take a couple of each. But you can actually mathematically figure out what's the best combo. I should take 2 of these pills and 3 of those pills, and I'll get everything I need, and it'll be the cheapest possible. Instead of taking like 6 of these, I can end up only taking a total of 5. And you might think, well, what's the difference? Some pills literally cost $10 for each pill. Okay, like there are medications where it's $10 for each pill. I know of an injection that's over $1,000 for one injection. Okay, so drugs can be really expensive. So if you can figure out a mathematical way to say, okay, I'll get everything I need by only taking 1 less pill. Well, if the pills are $10 each, it's going to save you $10 a day. That's a lot of money. 365 days times $10, that's going to save you $3,000 a year. Okay, so anyway, I'm going to do a problem with you now that's similar to this, and hopefully you've gotten good at taking 2 equations and going second calculate intersect. How would these two have looked? Let's show the people at home. It would be negative 2/3. Could I put that in parentheses like this? Or no, it's 3/2, sorry. Negative parentheses 3 divided by 2. Yeah, that's the safest way. And then it was, let me see, plus 6. Could you put negative 1.5? That would have worked too. Okay, but if you don't have the parentheses around there, it might not work right. The next one was negative 1/2. I'm going to put negative 0.5 x. Negative 0.5 x plus, and then that one was plus 4. And then I need to graph them and see where they cross. And was I done when I saw where they crossed? Nope. I needed to see where they crossed and do second calculate intersect. Now, did you have to shade on the one? No. Second calculate intersect. And enter, enter, enter. And there's a spot, 2, 3. Raise your hand if you were able to get it to 2, 3. Okay, good. That's the main thing I needed to teach you so far. Now, the new thing I need to teach you is about writing equations for situations, and there are a lot of times, there's a certain kind that everybody messes up. I want to practice it with you today. There are twice as many bagels as donuts. Let's say I make this bagels and this donuts. Let's say that you're buying treats for the office, and people generally like bagels better than donuts because they think they're healthier, even though they probably aren't. Anyway, so we always want to have twice as many bagels as donuts. That's an equation. Bagels is obviously x, and donuts is y. Can you write me the equation? Twice as many donuts as bagels. Okay, I know that that would be hard for you because that's why I'm bringing it up, because I know these are hard for people. So let me show you. Twice as many donuts as bagel. I would always start with them being equal. I know they're not equal, but start with x equals y. It's the best way by far. Now all I've got to figure out is which one needs to be twice the other one. Twice as many bagels as donuts. So everybody goes like this. Okay, bagels is x, twice as many bagels. No, that's wrong. Here's why it's the other way. Do you get, if I did this, twice as many bagels as donuts, and you put the 2 times the bagels, do you get that the actual points then would be things like, let's say there's 10 of these and there'd be 20 of those. Do you get that then there's actually 20 donuts and 10 bagels? It's exactly backwards. So if it says twice as many bagels, don't double the bagels, double the other one. Let me show you. Well, I think you'll understand this better if I say it this way. If there's twice as many bagels, which one is bigger, x or y? If there's twice as many bagels, what's bigger, x or y? X is supposed to be bigger. This one's bigger. Do you all get that? If it's twice as many bagels, that x is bigger, then why would you double the bigger one to make it equal the smaller one? See how that doesn't make sense? It's kind of counterintuitive. If they say twice as many bagels, you got to double the other one so that it catches up to this one. Does that make sense? If this is, there's going to be 10 bagels. Then there'd only be 5 of these. So I've got to double the smaller one so that it catches up to the bigger one. Or, if you can't handle all of that, just remember, if it says twice as many bagels, you double the other one. You don't double the bagels, you double the other one. All right, I'm going to give you another example. So, let's say it's, you're at an Apple store, and they're trying to sell twice as many of the better watch, the upgraded watch. This is upgrade, And I know how they're going to do this. And this is the normal. The normal Apple Watch at $350, they're going to run out right away. And then everybody who really wanted the $350 watch is going to have to either get nothing, or they can buy the $400 watch and only spend $50 more and you get a better watch. See what I mean? That happens all the time at Apple. You walk in thinking you want the iPhone that's got the 64 or 32 gigs, and I don't have any of them. But they say, but we can give you a 64, which is even better. Happened to me twice now. So they don't have the one that you really want, so you have to, well, I'm getting something better. You just have to pay more for it. So they get to sell more of their, anyway. I don't know if it's a conscious effort on their part. Stop. I don't want to hear the Apple hate right now. Okay, so anyway, the point is, in any store, if they don't have what you want, they'll try to upgrade you, sell you the thing that's even a little bit better. So if they want to sell twice as many upgrade watches, if they want to sell twice as many upgrade watches as the normal watches, again, these are Y and these are X just because of where they are on the graph. Write me the equation for that. So my advice was start with X equals Y, or Y equals X. Doesn't really matter which one's which. Then, twice as many of the upgrade. Don't put the 2 here, put the 2 there. Because this one's supposed to be bigger. So we've got to double this one to make it catch up and be equal. Does that make sense? So maybe you had that one right? Okay, good. Now write me an equation. We'll use D and C as our 2 variables. D and C, dogs and cats. Twice as many people are dog lovers than cat lovers. And this is an interesting true statement. It's roughly true. It's not perfect. There's about the same number of cats and dogs in the United States. How could that be if there's twice as many dog lovers? Crazy cat ladies? Okay. Yes, sir. Okay, so did you have twice as many dogs as cats? Because if you did, you screwed it up. There's twice as many dogs as cats. No, I'm saying that's wrong. I said you messed it up if you did that. If it's supposed to be equal and there's really twice as many dogs, this one's really bigger, right? So then we don't want to double it, the bigger one. We want to double the smaller one. Does that make sense? D equals 2C. Raise your hand if you got that one right. Okay, good. I think you're getting it. So let's imagine now we're in the middle of a linear programming question, and they say we want to build twice as many SUVs as trucks. And I'll put SUVs here. Twice as many SUVs as trucks. You got to figure out which one's which from this, the X and the Y, and then write me an equation. I want to sell twice as many SUVs as trucks. Okay, did you make this X? Did you make this Y? Twice as many SUVs. It's very tempting to put 2X equals Y. Always start with X equals Y, but don't do twice the SUVs, do twice the trucks. That way, the smaller number of trucks, when doubled, will be equal to the bigger number. X equals 2Y. Raise your hand if you had that one right. Okay, good. Now, in the end, you always want to solve them for Y, right? So is this one solved for Y? No. So this one, we'd need to get rid of the 2, so we divide by 2 on both sides. We'd have Y equals 1/2 X. All right. Yes?
Does this work for also for, they want to make it sell 3 times as many or
Yes, yes, absolutely. If we want to sell 3 times as many of this than that, it's the same idea. It doesn't work just for doubling. It works for tripling and quadrupling. All right. So now let's get into one of your homework questions for today. Did some good examples with you that made it take too long, which is okay, but we need to now get into your homework for today. This extra fit vitamin question. This one I'm going to help you with very rapidly because we have very little time left. And your assignment will be to do the last two on here, in the last one being Rachel's vehicles. All right. You know what? I'm changing course. I'm not going to have you do the Mrs. Wilson's vitamin one for right now. Instead, let's go magician's payment. This is very much like a problem that I've seen before on the ACT tests too. So it's a really good problem, and I'd rather talk over this one with you than that other one. All right, your school is contracted with a professional magician to perform at the school. Do we even need that for this? No, it's just kind of background. The school is guaranteed an attendance of at least 1,000. That sounds important. Now notice they've set X to be student tickets and Y to be non-student tickets. Do you get I already have an equation? As soon as they said an attendance of at least 1,000, and I know X is students and Y is non-students, in other words, they could be, adults or whatever, then who's got it? It's an equation. X plus Y is greater than or equal to 1,000. Why greater than or equal to? Because they guaranteed at least 1,000. Might be more. Okay. And total receipts of at least $4,800. Ooh, I don't know how much money is involved yet, so I can't make that X plus Y equation until I have how much for each X and how much for each Y. We'll do that on a different equation. Okay? The tickets are, here they are, $4 for students and $6 for non-students. So it's 4 for each X and 6 for each Y. Who knows the next equation then? Remember how there's always an equation with an X and a Y, and they also have how much each is? Come on, you can do this. What goes with the X? 4 for each X, and how much for each Y? 6 for each Y, and what does that give you? Well, this was how many tickets. This is money. When you take $4 and you times it by how many tickets, don't you have a dollar amount at the end? So 4x plus 6y is equal to some dollar amount, and they tell us that. What do they tell us? 4,800. Now, is it exactly equal to 4,800? No. They said at least 4,800, so what do we say? Greater than or equal to 4,800. All right. Now, of which the magician receives $250 and $450 respectively. Ooh. So that's called a profit function. Remember those? P equals something for the X plus something for the Y. The profit for the magician's going to be what? 2.5x, 250 for each X, 4.5 for each Y. That's the profit function. When you graph this puppy, you'll have to, solve for Y on each of them. And you'll get something generally that looks like this. And you shade greater than is above it. And then you have another line that, let's say, looks like this. And you shade greater than, which is above it. Remember how I said before, you might end up with a never-ending thing? That's because we guaranteed he was going to make a certain amount of money, but we didn't cap it. We didn't say, but no more than 3,000 people will come. Apparently, there could be an unlimited number of people. In the real world, it's really rare. Usually, stadiums have a capacity. The most you can get is this. So, this one's going to be one of those kind where it's not just like a little triangle you shade in. It goes forever in one direction. Oh, and look at me going into the negatives. Can't do that. Why? Common sense. Can't have negative people. Correct. Okay? So, couldn't you? All right. So, anyway, if you shade above it here, then let's say there might be 3 spots to check. What do I check them in? My profit function. I check the X and the Y from these 3 points that you got to find. Your calculator will help you tell where they crossed. Some people will have trouble with this point because they'll say, but there's only one line. No, there's another line running straight up and down at X equals 0. So you'll have to do that second calculate value of x equals 0. That's how you do this point here. This point here, some kids will say, but there's only one line. The other line's running this way. That's y equals 0. That's easy to type in your calculator. That's the line y equals 0. And this other line that it's touching, you'll have to get that from one of these two equations. All right, I'm giving you guidance towards answering this question. Now, you have to grind it out and do the rest of the work. You have to make a nice graph. You have to see where those 2 points cross. Exactly, what are those numbers? You have to take those numbers and stick them into this profit function and see how much this guy might make. Yes?
What do you think is
You've got this equation and this equation are your two equations you're going to put into your calculator. You have to solve both of them for y, and those are your two equations. That's like this line and this line. Okay, that's all I got for you for today. Have a good day. Good day.